So I am absolutely delighted, and we are delighted to welcome today as our keynote speaker, Professor Jennifer Chayes. Professor Chayes is Associate Provost of the Division of Computing, Data Science, and Society, recently renamed CDSS, as we're calling it now, and she's also Dean at the School of Information here at UC Berkeley, where I work. Professor Chayes is the inaugural appointee to this new role on campus. And since officially starting at Berkeley in January, she has already set forth a really exciting vision for building multidisciplinary groups, seeding research at Berkeley in areas that bring people together from across the campus, and encouraging people from underrepresented groups to pursue careers in STEM fields, among many other innovative strategies and developments, which I know she'll be speaking about in her talk. Professor Chayes has held many distinguished roles. Most recently, before coming to Berkeley, she was a technical fellow and managing director of Microsoft Research New England in Cambridge, Massachusetts, which she co-founded in 2008, Microsoft Research New York City, which she co-founded in 2012, and Microsoft Research Montreal, which she began leading in 2017. Professor Chayes is a member of the National Academy of Sciences, a member of the American Academy of Arts and Sciences, a recipient of the Anita Borg Women of Vision in Leadership Award, and she personally mentors several dozen women at least. If we were to network it out, I don't know if we would exceed several dozen. Professor Chayes has also been involved with women in data science since the inaugural conference at Stanford that many of you heard about this morning in 2015, at which she also delivered a keynote address. And she was the first person interviewed, I think, for the WiDS podcast. And she has also spoken at WiDS Cambridge in Massachusetts. So this is the culmination of a long and wonderful involvement from her with this conference. So I know she'll also be speaking to you today about her path. So I'll leave further biographical details to her. And please join me in welcoming Professor Jennifer Chayes.
Okay, well, thank you so much, Catherine. WiDS is really a great endeavor. As you heard, I've been affiliated with WiDS from the start, and it's great to see all of you here. I like to have some idea of whom I'm speaking with. So, are all of you Cal students, staff, faculty? Is there anyone who's not part of Cal but who's awesome? Okay. So I guess I can't go and ask each of you what you do, but I assume maybe you're from the lab or from industry or something. Yes? Anything else that yes? Okay. Fantastic. Okay, so we have a real cross-section here, which is wonderful, which is what I found at the first WiDS meeting. It was pulling in people who were not even necessarily doing data science, but were interested in data science for themselves. So, maybe a path in data science. So I will tell you a little bit about my very unconventional path. And one of the reasons I'm telling you this is because you don't have to have a particular background to go into data science. It's really an opportunity for all of us to get on this path if we want to. A little bit about my research. It'll be data science on questions of inequality and unfair representation of people through machine learning and what we do to mitigate that. And then my new gig, I'll talk a little bit about the new division of Computing, Data Science, and Society, and I forgot the comma there, but there should be an extra comma. Okay, so long ago, here's me, like 1969 or 1970. Okay, I was talking, which I still am. The people who know me, it's like, yes, she was talking. And I went from there. I was kind of an adolescent to being a high school dropout. So you see, you can get back on the path at any point. Okay, what I learned from that is how to question authority and how to blaze new trails. So all of your experience can be relevant. I got back on track because I was a good tester. And the world was much more forgiving back then. Now, you have to be this perfect high school student to get into college. Then all you have to do is get 800s on your boards, which you probably even have a different scale at this point. So I got into Wesleyan. I became a good student. I was a double major in biology and physics, and one course shy of a math major and one course shy of a chemistry major. I really loved science, and I took 2 non-science or math classes at this liberal arts school with no distribution requirements. Oh, and I took a coding class in my freshman year, which was 74, 75. And that was my last interaction with computer science for many, many years. Okay, I went on to Princeton. I had thought I wanted to go to medical school, but I fell in love with physics. So I did mathematical physics. Even there, when I was being a high school dropout and all that stuff, I loved math. My mother cannot add fractions. Her mother was married at the age of 9. And for some strange reason, at the age of 4, I started going and asking neighbors to give me math problems. So kind of a little strange. So here I decided to pursue my passion, which is another lesson. I love mathematical physics. I love math. I love physics. I love proving theorems. So that's what I did. From there, I went on and I was a postdoc in both math and physics at Harvard, proving theorems. Postdoc in both math and physics at Cornell. I had real fun with that because I used to stay up all night and the experimentalists stayed up all night. And they didn't realize I was a theorist. They would come to my floor looking for a solid state or a condensed matter theorist. And they'd have all this data that they were like getting off their machines. And they didn't realize that I wasn't supposed to know about data. And so they would bring me data and ask for my interpretation of it, which was actually really fun. And I got thanked on papers and stuff. So that was really fun. And then I became a professor at UCLA in 1987. I worked so hard. I did 2 postdocs because everybody said you couldn't get a job in mathematical physics. And I was married at the time. I was married to someone different than I'm married to now. It happens, I got married at 19. That is something I don't suggest you do. Okay? But I stuck with him for 15 years because I hate to admit I'm wrong. Okay, so it's like, no way these 2 people are going to get jobs in this obscure interdisciplinary field. Interdisciplinary was a bad word then. Interdisciplinary, multidisciplinary, I'd never even heard that word. So we worked really hard in 2 postdocs. 3.5 years out of grad school, we got 2 tenured offers together in 7 universities. So we did okay. The same drive that got me to drop out of school and go and campaign in, campaigns to try to get out of the Vietnam War and stuff was kind of driving me there. Okay, so I was a mathematics professor. I was proving theorems. Then somebody I'd met at Princeton who was in my, by the way, when I was at Princeton, the 4 years I was there, no other woman got a PhD in math or physics, which were the 2 things I was doing, okay? I would go to conferences of 100 people, and I was the only woman. And when people would say that there was discrimination, I'd say, you're crazy, I don't know what you're talking about. And I really didn't. I think it was so bad that I just blocked it out. The head of graduate studies when I was at Princeton, I know this is a little random, it's like one of those movies that keeps jumping forward and jumping back. The head of the graduate program, the faculty member who's head of the graduate program, went to the faculty and he said, I suggest that that none of you take Jennifer and Lincoln, that was my first husband, as students, because they're going into this obscure field and they'll never get jobs and it'll be a waste of your time. And when I heard that, I didn't say like, that's discriminatory or that's, it's just like, he's wrong. He's wrong. I didn't even realize, he's factually wrong. We're going to get jobs, and we got out sooner than anyone in our class, and we went on to Harvard and blah, 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 and within 3.5 years we were tenured. So, but I was just doing math and physics. Then one of my classmates from Princeton, called my first husband my pet gorilla. Lincoln was actually a cool guy. He came to me and said, so he turned out to be the first CTO of Microsoft. Okay, and he came to me and he tried to convince me, and my second husband, who's still my husband 25 plus years later, and who's awesome and who's in EECS here now, said to us, why don't you come to Microsoft? And I'm like, why would I want to go to Microsoft? I mean, I haven't coded in 15 years, and actually what I said to the poor VP who had to call me and try to get me to come in for an interview, talked to me for like 45 minutes, and I finally said to him, can I tell you why I really don't want to come to Microsoft? And he said, yeah. And I said, well, because it's a bunch of adolescent boys, and I don't want to spend my life with a bunch of adolescent boys. No, it's not that. It's not that. So when I got there, he found a couple of women for me to meet with. Adolescent boys. And so they kept asking me what I wanted to bring me there. And I think I was supposed to ask for money or stock options. Got a really bad deal for myself, actually, money and stock options. I was coming as a University of California professor, so anything seemed like a lot of money to me. But anyway, I said, well, can I? Because I really wanted to start multidisciplinary groups. So I was like, well, could I have 6 researcher positions? And they're like, that I could fill with anybody I wanted. And they said, yes. And I said, could I have 6 sabbatical visitors? And they said, yeah. And I said, can I have 6 postdocs? And they were like, yeah. And so, I said, okay, well, I have to either go there and build this interdisciplinary group or forever hold my peace. And anyone who knows me knows I can't hold my peace for 2 minutes, never mind forever. So I went there and I built, and I didn't know anything, and my research had been on physics. It had been on these disordered systems, which I represented as these random graphs. And a couple of years after I got there, my boss said, I heard this great guy, John Hopcroft, who's a Turing Award winner, speaking about this internet thing, and it kind of looked like your random graphs. And I'm like, wow, it does kind of look like my random graphs. And so I started doing research on algorithms on random networks, and it took off from there. And I landed up, after 11 years there, I was kind of bored, and I convinced Microsoft to let me go to Cambridge, Massachusetts, and found a lab, and that lab was around economics and anthropology and sociology and some legal scholars, and also it turned out biomedicine, which was great for me because I had started out as a biology major. And so I built that, and then the New York City lab, and then the Montreal lab, and along the way a little lab-lit in Herzliya, Israel. And so, I had amazing researchers. I worked over all these years with about 200 grad students and about 100 postdocs who came through my labs. They were super successful. So I spend about 20% of my time now writing letters of recommendation. I'm not kidding you. I'm not kidding you. I write 50 letters of recommendation on 50 different people every year. They're awesome, they're incredible, and they're changing the world. And I had hired some of them. And so, but then this opportunity at Berkeley came to me, and I said, okay, this is the one. People were coming to me for the last 15 years, you want to come and do something at a university. And I'll spend the end of the talk talking about why this is the one. I mean, this is the most amazing thing that we are doing here together. But first, a little bit more about my research and me, and oh, there we go. Okay, so start out physics, mathematics, computer science, and network science, which was all about these random networks. And then along the way, applications in economics, biomedicine, climate change, and fate. What is fate? Fate is a name that some people have given to a new field. It has to do with fairness. Okay, so an example is to ensure unbiased algorithmic recommendations for hiring. So I'm going to talk about that, but there are all kinds of algorithmic decisions made now, you know, on bail, on all kinds of things. And so how do we ensure that those are fair rather than less fair than human judgments? Accountability. How do we do things like monitor non-discrimination compliance on loans, things like that, okay? Transparency or interpretability. You know, we can't just put everything through a deep neural net because then you won't know where the recommendation came from. If you're the FDA trying to make a decision about whether you can use a certain medical intervention, you have to understand the logic of that recommendation. And then ethics, because some of the original work in this field was using the acronym FAT, and still the biggest conference in it is FAT. Anyway, ethics. And, you know, ethics encompasses all of the above, and privacy and other things, and governance, which, by the way, I think we have the most amazing scholars in the country in this area. I hired one of them 12 years ago from the iSchool who helped to found the discipline of fate in my labs. And I think the iSchool here and my labs there were the absolute leaders, and we have incredible people here. Okay, so fairness. So machine learning tools may actually do worse than reproduce. They augment different forms of discrimination and injustice. Okay, and why do they do that? Because they're trying to optimize something. And if you optimize it, if I'm trying to look at what characteristics are correlated with being a good software development engineer or a good data scientist, I'm going to get male as an attribute because most data scientists and software development engineers are male. So if I don't watch out, I'm going to take in data that is already biased and I'm going to augment that. Okay. And even if we don't use protected attributes like race and gender, the ML algorithms find proxies for them. Okay, if you see in somebody's resume that they were on a football team, I'm not allowed to use maleness, but I see football in their resume, then that's a proxy for male, and the algorithm is trying to fix on male, okay? Potential harms, allocative, I don't get the loan, or I don't get into school, or I don't get a job, or representational, how I'm represented to the world. So we want to understand and mitigate circumstances and mechanisms by which unfair treatment may arise. Okay, so word embeddings are the backbone of text-based models. There's roughly a 300-dimensional space which has all words and how close they are to each other in terms of being used in the same sentence, being used in the same way. And you get this 300-dimensional space, which is actually a really interesting space. So, for example, if I take earrings and I take mommy, and I subtract daddy, where I go in the space is to ties. So this tells me that earrings are to mommy like ties are to daddy. And you get these these analogies out of this 300-dimensional space. But in fact, what's really bad is that the geometry is encoding bias present in the training data. This has come from petabytes of text, okay? So we see that the ones that are closer to maleness are brilliant and genius. And we see, females, dance, pageant, beautiful, right? We don't see brilliant or genius associated with that. So it's really, really bad. So then what you want to do, what some of this early work up here did, was it just took things that shouldn't have a gender basis and it moved them to gender neutral in this space, and then used that as an input for search engines and stuff to come up with better recommendations. And the result was more gender balanced results from text models. So with some grad students and colleagues, we did a study of bias in biographies and CVs and other texts. So we first had a case study of semantic representation bias in high-stakes settings. I'll talk to you for a while about that. That appeared in the conference Fat Star. They put on a star so that it would sound less bad than fat, but that was fairness, accountability, and transparency. It's the biggest conference in this area. And then later, the same group of collaborators with Alexei taking the lead on that one. He initiated the second one. What's in a name? Reducing bias and bias without access to protected attributes. So this won a Best Paper Award in the biggest natural language conference because this was without. So in the training, we identified stuff that we then use when we're rolling it out to not use any protected attributes, so that places that are prohibited from law, like in loans, I'm not allowed to use a protected attribute. So I can't compensate for the fact that someone is a person of color by using that protected attribute, because that would be illegal. But how do I manage in the training to mitigate some of that bias so that when I roll it out, I can actually make sure I'm not using that bias? Okay, so machine learning and natural language processing in high-stakes settings. So one of our grad students was Maria de Ortega Gonzalez. And so when she goes onto her webpage, she sees certain jobs recommended to her. These are ads that are placed on Google recommending jobs to her. There's an increasing use of machine learning in this domain of what ads get presented, or what, even automatically in a company looking at whose resumes am I gonna look at more and call back for interviews. Okay, grave consequences over people's lives. And there's a lot of work showing how bad this is. So what are the risks of implementing machine learning algorithms in the recruiting pipeline? And a couple of years ago, Amazon really just got nailed for this. And their internal tool, sexist AI, it was representing men. It was suggesting men even more than the background applicant pool. They pulled it out. Probably everybody was doing this. Amazon just got caught and got put on the, on the front page of the business section. But a lot of people are doing this. So our contribution in the first piece of work, and that's the one I'll focus on for now, is a large-scale study of gender bias in occupation prediction using online biographies. So what did we do? What was the data and task? We scraped 866,000 third-person web bios from the Common Crawl. Okay, so this is a data set. We went and we scraped bios. So what made a bio? What did we call a bio? It was something that said first name, last name is A or Ann, and you have a profession, and then it talks more about the person with he, she, and the title So one of the criteria is that the title had to be from the Common Bureau of Labor Statistics Standard Occupational Classification, which was like 33 job categories. Okay, so this is another one of our collaborators. So she's a CMU professor. So Alexandra Sholtashova is an assistant professor of statistics and public policy. Blah blah blah. She, her, blah blah. Our task is to predict which occupation she is of these 33, leaving in the gender markers. Okay, he, she, the pronouns. And also you predict it without the gender markers. So here were the demographics of what we scraped. There were a lot of professors, because professors have biographies on their web pages, and others write about them when they're giving a talk. There were lots of other professions too, and this is just the breakdown, this random scraping of things which satisfied the XXX, first name, last name is A or An, one of the 33 professions. Okay, and so this is the breakdown. It was 56% male, 44% female among all these different professions. And so we had a learning pipeline. We input the biographies. We used different models. We used bag of words model, which is like topic modeling. We used word embeddings, that big space. We use deep neural nets with attention, and attention is really interesting because not only tells you what the result is according to the deep neural net, but also what are the words in the bio that were used the most to get to that classification. So it's kind of interesting. Okay, so here's so here is the bio of actually one of our co-authors. And so we asked, after we trained on these 866,000, we asked to predict the title, and it predicted that she is a teacher. It said mathematics. Of course, you see mathematics and you see a woman and you assume she's a teacher, right? Machine learning, blah, blah, blah. Okay. We switch it to he, and same bio, software engineer. And this was, when I was at Microsoft, this was really compelling because I take executives at Microsoft and I would pull their bios up, and on our online tool, we would do it in real time. And they were like, oh my God. You know, there'd be these women who led engineering teams of 1,000 people, and they called them journalists, and you switch it to he, and they're like, you know, I mean, it was stunning. So what happens is that so you've got these pairs of professions, and if you switch she to he, 15% of the time a teacher goes to a pastor. If you switch he to she, a surgeon goes to a nurse, okay? And it gets similarly confused on nurses, okay? Because the assumption is that nurses are females. So what is a metric? Well, there's something we call gender sensitivity, which is this fraction that changed classification when you switch he to she. Obviously leads to disparate treatment. Can we achieve any kind of blindness? So we talk about the gender accuracy gap. So T is a profession, so let's think data scientist. G is a gender, male, female, or not determined. So it was clearest with he and she, but so what we did was we took, because most gender stereotypes are around people who self-identify as he or she, although the worst are probably among people who do not identify as he or she. The most unfair, inaccurate. And so true positive rate. So somebody who is a data scientist and a male, so you're a male, you're a data scientist, and what is the true positive rate that I identify without gender markers, your bio as a data scientist, minus you are a female data scientist, the true positive rate, you are, and I identify you as such. And that, okay, so if there is a non-zero gender accuracy gap, it leads to disparate treatment, and it compounds imbalances and injustices over time. Deborah Hellman is a legal scholar who shows the effects of repeating this over and over again, right? Because what happens is when you recommend, when Silicon Valley companies are, because of this injustice, calling in for interviews and hiring fewer female data scientists, then the pool gets even worse and the injustice compounds. Okay, so here, when we leave the gender in, still, these are more accurate on females. These are more accurate on males. Here, it's okay. But what happens if we scrub gender? Now, a little bit of a story. A pianist is coming in to audition in an orchestra. The auditions in orchestras were just terrible. I mean, overwhelmingly, when they saw the musicians, they would choose males. I mean, just overwhelmingly. So, literally, they started to put up curtains. So this is like scrubbing the he, she, okay? It got better, but not entirely better. They noticed that the click, click of women's shoes was a proxy for gender. Okay? And when they had them take off their shoes or all wear similar shoes, it got better. So you remove the protected attribute and still there are proxies. And believe me, in the writing, there are proxies. I'll tell you something interesting. I came up with reasonable professions. And years ago, somebody had put in my bio, when they wrote a bio on me, world renowned. And I thought, God, that makes me feel really weird. Why don't I try just leaving that in my bio? And the attention showed, the thing it honed in on was world renowned. More than cryptography and this, that, and the other thing, it was world renowned, because it's usually men who call themselves world renowned. Okay, so proxies are in there. I'm sorry, but that's really true. So, okay, so this is telling you, like in an occupation which is 50-50, it's always pretty good. As you go more to one side or the other, it's bad. The blue one is if I don't scrub the gender, but even if I do scrub the gender, it has found proxies. Okay, this is bag of words, word embeddings, deep neural nets. So still bad. And over time, these compound because the pool gets more and more concentrated. Okay, so that's what we did here. How biased are they? We created this database that others can now use. And in this second piece of work, which I don't have time to tell you about, we use the implicit cultural biases in names. There are names that are associated with males or females. There are names that are associated with races and ethnicities, okay? And we penalized our DNNs for correlations between accuracy and names. And then we did that in the training phase. And then in the test phase, when it's actually being used, okay? When it's actually being used to make judgments, we didn't have any of that. We had it in the training phase. And it reduced the gender and racial and ethnic gaps tremendously. And it won the best paper in this natural language processing conference. Okay, so that's what we did. Now, why did I come here? So, our division has been recently renamed Computing, Data Science, and Society. Okay, we use computing and data science, and we pull in every other discipline and work closely with them. So the society is the welcoming in of every other discipline and the aspirations that we have to have societal impact. So What we have is that EECS is partially under College of Engineering, partially under me. I mean, they're reporting through both of us. Same with statistics and College of Letters and Sciences. The iSchool is entirely in here. Berkeley Institute for Data Science is in here. The Data Science Education Program, which is the most amazing program, is in here. And we're building something called the Data Science Commons, which will hold faculty. Okay, so the vision is to educate the next generation to approach data ethically and masterfully. I would like every student at Cal to get training in data science a little bit, because you can't, you don't know how to question the biases inherent in data. You can't be a citizen in this world and not know how to question data. You don't have to be an expert, but you have to know how to question it. We want to advance the state of the art in our core, that's computing, data science, information, and statistics. We want to found new fields at the boundary between computing and data science and all the other areas on campus. Talk a little bit more about that. And we want to make real progress on issues of societal significance. And we take this vision, these goals, very seriously. So why Cal? Well, we have tremendous strength in the core. We also have excellence across all disciplines. I mean, we have a law school. We're affiliating now with UCSF, so we'll have programs with a medical school. We have public policy. We have a School of Social Welfare, Graduate School of Education, Division of Biological Sciences, and Public Health and Public Policy. Commitment to societal impact. I have never seen a group of faculty and students who have, who believe so deeply in having societal impact and have such a commitment with their blood, sweat, and tears to make it happen. And then, we take in the most diverse population, and we are doing this at scale. 6,000 people, 6,000 Cal students a year, or 6,000 Cal students have taken a data science class. Okay, so our strength in the core is in our core disciplines, excellence across disciplines, and this is why I had to come here. Like, people are like, why did you take an 82% pay cut? Which I did. Why did you give up these researchers you had handpicked and this great research and impact on software that was used by 1 billion people? Because Berkeley has incredible strength at the core, excellence across all disciplines, commitment to societal impact. I mean, when I talked to the faculty and students here, I was just blown away. The data science major came from the faculty and students working and putting it together out of nothing. And inclusion and scale. I mean, it's just unbelievable. We are forming something called the Data Science Commons to bring cross-campus interdisciplinary partnerships together. We have 8 themes, and every one of the divisions, the colleges, the schools on campus fits into one or more of these. Responsible and ethical AI, this is the FATE kind of stuff, that reaches across so many disciplines, and similarly for all of these. Okay, human welfare, for example, the Graduate School of Education, the School of Social Welfare, the School of Public Health. So here are some of the others and which things they're going to involve. So, biomedicine, we've already put in a proposal for joint faculty in computational immunomics, a really important field. Responsible and ethical AI. I mean, for our core, the iSchool has been doing this for over 10 years, so we're really ahead. But Division of Social Sciences, School of Law, School of Public Policy, College of Engineering, School of Public Health, Climate and Sustainability. If we don't get this right, and the solutions to climate and sustainability are going to be data-driven solutions. If we don't get that right, we have nothing. But we will get it right. And our provost said this is by far the greatest transformation Berkeley will undergo for decades. And it is the biggest reorganization since the reorganization around the biological sciences in the 1980s. But I think more than that, this is the reorganization that is going to bring everybody together to do data science, computing, and have societal impact. Thank you. So I don't know if there are any questions. I know I'm standing between you and your lunch, but let's see. Maybe a couple of questions. So should they be? Yeah.
Wonderful talk. Thank you so much for sharing that with us. So as data science is growing and all the different sciences as well are permeated by computation right now, what are the plans, particularly within the data science, to take computing to these all different disciplines?
So this is exactly what we're doing. We are gonna, so you saw fundamental sciences were down there. That's chemistry and math and physical sciences. I mean, I have just been talking with everyone on campus. It's been amazing. I've only been here 2 months, and I've been making all of these connections because yes, there are new data sources. There are new questions that can be approached with existing data sources for which we didn't have the analytical techniques that we now have. If we don't connect with all of these disciplines, we will have failed, but we're on track for succeeding. We are going to get there, and really, we're going to transform. And by the way, it is not one way. It is not computing and data science saying something about other fields, okay? As we think of responsible and ethical AI, we need the ethicists, we need the legal scholars to help tell us what are the right questions. We need the historians to put this AI revolution in historical context. When we think of doing human welfare, it is going to be the high school teachers who are out there as our alumni from the Graduate School of Education, and the social workers who are out there from our School of Social Work, and the public health workers who are out there from our School of Public Health, who are meeting with us and convening in one building. We just got the biggest gift in Berkeley's history for our new building. $252 million from one incredibly generous anonymous donor. Okay. We still have a lot more to bring in because the building has to be huge because it has to house all these
Does it
people.
contemplate the scaling of the computational infrastructure to actually serve all
Absolutely. Absolutely. So, but we are going to be convening all these people. So it's not going to be a one-way, let us come and analyze your data. It's going to be a, going to all these other disciplines and saying, what are the questions that you care about, and how can we iterate, and how can we build on these together to solve some of these problems with our students. And then you will begin to learn about all these applications in your data science classes, and you will be the people who roll out these innovations to the world.
Thank you.
Yeah? Well, okay, I guess we have to go through with the mic so that people can hear. Yeah.
Thank you so much. Really inspiring words. I have a related question. At a time when the higher education policy is being shifted to having funding follow the number of students that are being served by specific departments or disciplines, where does that leave the humanities? Where does that leave, the smaller sort of graduate programs that you were just touting that require seminars? How does that disparity kind of create a system where the sciences and data science are at the top of the north, or the rich, and then we have the wealth, social welfare and education, which is where I'm coming from, that are kind of potentially getting pennies to the dollar. So
Right.
how do
So
we, and as a data
Prudence
scientist,
Carter,
how could
who
you?
is that? Right. So Prudence Carter is the Dean of the Graduate School of Education. And Linda Burton is the Dean of the School of Social Welfare. Okay? And I said to them, when I met them, they were like, oh, well, we're not going to get any of this. And I said, you sure are. You sure are. It is my responsibility to work with the dean and the faculty of the humanities and of all these disciplines. Believe me, there are going to be donors who are deeply interested in using a data-driven approach for the child welfare system, which involves education and social work and public health, okay? So the idea that this has to leave behind those disciplines is crazy. Our most transformative work is going to be in these disciplines because these are the disciplines and the areas that have been left behind so far, and so the ones that are going to be the most ripe to transform and move forward with. And really, I mean, I think in all these, in the humanities, I'm thinking of whom I might go to as a donor. In education and social welfare, I'm thinking of whom I might go to as for a donor who could give us joint faculty and students and everything in these areas. This is a rising tide. It is going to lift all ships, and some of those underrepresented schools are going to be in the lead with us.
Thank you. And I'm just as a new bioinformatician, also part of the data scientist, and also who's not part of UC Berkeley. I'm sitting here and jealous, like, wow, they have fabulous resources. So this program is so fabulous. And then I start to think, like, do you guys have any idea or like potential plan that you can open up these resources or open up some like reach out programs, extensions that, so for us who's not currently belonging to UC Berkeley can get these cutting edge skills too.
So where are you from?
Right now I'm working in the industry, biotech.
You're working in
industry, yes, biotech company.
Biotech. Well, biotech has, it's kind of interesting.
Yes,
to hear
startup.
People say that Cal has resources and biotech doesn't. What we have is we have dreams and we have scale and we are going to change the world and get resources. Right now we are big in dreams and small in resources, but we will get there. We will get there. So I think biotech probably has some resources. But no, seriously. But as we develop resources, everything's going to be open source. Everything is going to be, and we'll probably start some professional master's programs, but we'll have, scholarships for the people who can't afford them. And we will, so I know I'm making it sound like we have a lot of resources. We have a lot of aspirations, and we do have this one. I've only been on the job 2 months, and they loaded the bases for me and then brought me in, so I look really good. Okay, we have this one transformational gift, but we have to do a lot more, and we will get there. And as we get there, I don't want to just lift the tide of Cal. I want to lift the tide. I want to raise the tide. My parents are not from this country, and I mix up all my metaphors. So, yes, okay.
I don't mean to be difficult, but where's the business school in this? Because,
oh my God, Ann Harrison and I are talking all the time.
Okay, because business controls the assets and the resources. So unless they buy in, I'm waiting because I was.
Okay, I want you to see this. Okay. And I worked at a company for 23 years, okay? Using machine learning, we transformed the back end of a lot of Microsoft. Amazon's back end has been transformed by these new forms of machine learning, which allow you to make causal inference and therefore make the right decisions without doing an A/B test. Okay, we transform a lot of the back of Microsoft with this on things that they would not possibly want to do an A/B test on, like, do I send my best salesperson to my best customer? You don't want to mess with that, okay? And this is going to revolutionize business. Every MBA student is going to have to know about this. And I'm even talking to Ann Harrison, who's the Dean of Haas, about doing joint masters and things like that. Absolutely. There's no question. I mean, it's here, and it's here for good reason. Now that, I'm not emphasizing that to someone from the Graduate School of Education, which feels like business, but there is transformation of business is going to be there, and the people who are going to lead it are going to come out of our joint programs. Absolutely. I've been at a company for 23 years. I've been speaking ROI speak for, before some of you were born.
Jennifer, I think with that, we have to start moving into lunch. Thank you so much for this wonderful talk.